Okay, welcome to the first Smart Aquaculture with Computate live stream. Today, I want to show you how we're going to uh, we're we're going to deploy. We've already deployed Smart Aquaculture workbenches to an OpenShift Red Hat demo environment, and now um, we're going to use the workbenches. So this is my first live stream with Zoom. Let me see if this is working. Okay, so good. I'm going to share my screen. Share. Oops, there we go. Share my desktop and I want to share my latest video that was how this demo environment was created. So this is the link. I'll put it in the chat. How the Smart Aquaculture demo Red Hat demo environment was deployed. And I want to take you to my website where you can get more information. My homepage has the information you need. The link to join the webinar, which started just minutes ago that you're watching now, you can join us free on Zoom and interact with me and ask questions. So I'll have this chat window open. If you want to know more about smart aquaculture, you can tune in Monday, Tuesday, Wednesday, Thursday. No, Monday, Tuesday, Thursday, Friday at this time and read more about the use case for smart aquaculture, how it got started, and then let's see, I need to put better links to the events going on. So we have our next event is next week on Thursday. We're doing this workshop that we're presenting at the NEDC 2025. This code generation workshop. We'll be learning how to develop the custom smart aquaculture data-driven websites and open APIs in the cloud and build your own secure IoT platform with generative AI, zero trust access control, and interactive dashboards. And the other event is in May at the Red Hat Summit. And it's going to be basically the same workshop and the same people there, but in Boston on Tuesday, May 20th, 2025. So this is what's going on for Smart Aquaculture. Since this is my first live stream, I want to make sure everything's going just right. Okay, so my screen is being shared. Good. Okay, thanks for bearing with me. And so next, let me share this environment. Let's see, let's go to, let's see, where is it? Sec. Okay, I'm going to share my screen. Okay, share my desktop. All right, I'm back. Okay, so this is our cluster. All right, and with the deployment, we've already been able to deploy 2 workbenches. So if I go to data science projects and I filter by name, workbench, there's a workbench for computate and a workbench for user 1. And the automation will create as many users as you want. As for a conference, you can create as many users as we need. But I just created these 2 to demo. So I want to show the code generation with user 1. So user 1 will be able to see their data science project, and they'll be able to click on workbenches and then access this VS Code workbench. So it's already running, and we open this workbench here, and this is the workbench. So we're going to follow these Jupyter notebooks in the workbench to get started. Okay. So so this is where it starts with the code generation, with the Computate Smart Website Builder. So what we do is we're here in a Jupyter notebook, and we need to switch to a Jupyter kernel called Bash. First, wanted to hide the video panel there, and then we go to this section about create your project. We update your variables. So if I run this command, it's going to show our variables that have been defined for Smart Aquaculture. I run this, and I switch to Jupyter kernel bash, and this shows you where the vars are defined. The home directory for this workbench, which is actually Linux, a Linux workbench, is /opt/app-root/src. And then we cloned a project called Smart Aquaculture, which is found, let's see, it's right here. This is the Smart Aquaculture project. And the only thing in it is this file called vars.yaml. So the vars are defined here, and it uses a ton of Jinja template syntax. So you can always reference things, a variable from above, or look up an environment variable, or look up a Kubernetes secret or an OpenShift secret within the vars, so that you don't have to store any actual passwords in your vars file. It just looks them up dynamically, which is really nice. So we're going to generate some code. We come here, and the first thing is we're going to create a launch.json, because you can run code. Actually, it was already pre-created, but this is what it looks like. So if I If I delete this, now it's currently empty. We're going to recreate it with this Ansible automation. So we run this command and we should see it appear. Yep, there it comes. So we're able to rebuild the launch.json here automatically following these steps. Next, we're going to install a gitignore file in the project. So let's run this and look here in Smart Aquaculture, it just added this .gitignore file. So this will ignore some of the stuff that we don't need to commit to source control that may have hard-coded paths or other things that we don't need in source control. Next, we're going to install a pom.xml, which is where the Java dependencies are stored in the project. So this creates a pom.xml, and there's a lot to this, but it has all the versions that we need and the dependencies to run the Smart Aquaculture project with all the computate dependencies and other dependencies that we need. So that's created. We're just creating this whole project called Smart Aquaculture. This is how the project began, is running the computate smart website builder like this. So then we generate a config_keys.java file. This is a file where we define our environment variables, basically, but it also extends an existing one. So if we go to Smart Aquaculture src main Java org computate Smart Aquaculture, here it's defined and it extends computate config keys. And if you look at this has a bunch more stuff in it out of the box. It has the code that actually evaluates the variables and queries things in OpenShift or queries environment variables. And these are the vars. So these are all the environment variables that you can tweak in your container image or in your container to adjust how the site works. So we have that now. And oh, that one's out of the box. We generated that. So we're generating a ton of code. We're going to generate the site request.java next. And site request is, it's a Java file that tracks information about the current request of the user. And let's see, we need to refresh this directory. Okay, so site request.java, there it is. So it generated this source code. Oh yeah, there it is. I was a little lost. We have the config keys. We have the site request on the left. Yeah, this is information about the user and the session, the user info groups, whether we have public read on something. Anyway, a whole bunch of request information. And then we create a base result. Now, computate projects like Smart Aquaculture use a search engine called Apache Solr to query data. We also use a database called PostgreSQL, which is for persistent data that's changed by the user through a form. But some things don't require a database. They're just like, they're a one-time import thing that's either imported from a file or something, and we don't actually have to change anything in the database, which is when we create a base result model. And so this is the base result model. And we want to refresh. Let's see, over here. I think it takes a little bit of time for the, oh, there it is. There's the base result. Okay, this is Java class. for querying the search engine. And the base model is for persistent models in the database. Refresh. Aquaculture source model, base model. There it is right there. Okay, next we're going to create a package info. This is specific to Vertex service proxy API code generation, because we generate a lot of code, but the Vertex service proxy API generates a bunch of that as well. Not just the Computate project generates code. Now we're going to create a new repo for static content. So we're going to start with the site.css, which has the basic web page style sheets for our project. So refresh. It should appear eventually down below, I think. We're going to generate some more static content, site.js, which has some basic JavaScript functions that we'll use in the site modules.js. A JavaScript module is something that runs when the page is completely loaded. Here's our Smart Aquaculture static. So we're generating some JavaScript and some CSS, and then we're going to add some default libraries, because sometimes when you're accessing these default libraries through their public URL, they might be slow to load. And so we want to copy them locally so that they're always fast when we're accessing these resources, because I've had slowdown problems querying Leaflet. Leaflet is for maps and graphs in a website. So that's why we're including Leaflet. And then we are going to include sock.js, which is for WebSockets, which are the cool effects that are event-driven changes to what's on the page. If somebody else changes something like a model, we can get a notification that automatically updates the value that they changed on the page. And so these two files, sock.js map.json and sock.js.js, they're related to that. Plotly is more mapping software and graphing software. Vertex Event Bus is part of that. Event-driven WebSockets in the page. And then we're creating a default logo for Computate and then a logo for OpenShift dedicated, although Google Cloud, I don't think we need that one. I could actually take that one out. Now this is interesting because this is a shell script that will regenerate all the code for the Smart Aquaculture project using the Computate software. And this one is another one. Both of these generate code, but one is faster. The top one is for if you've never generated the source code yet, you run this and it indexes them 3 times and generates the code. This one only generates the code without indexing the data. And then watch is for watching your project for changes and automatically generating the code, as well as watch now. Index.sh is for only indexing the source code, but not generating the source code. It doesn't generate any code. So we create those. Next, we're going to create a container file for to create this into a container image that can be deployed to the cloud. But we're going to run it in the cloud from this VS Code workbench. We create a page layout.java, which is used when a visitor accesses a page and there's a bunch of fields. Um, it's used to help render the page on the back end. So that's what page layout.java is for. And now we're going to create a bunch of static content inside of our Smart Aquaculture static directory. But instead of CSS and JavaScript, we're going to create some HTML templates and site page.java is for all of the dynamic pages that we create in the site. Okay, next step is we're going to index and generate some more source code. So we run this, generate.sh. Okay, we got a error. Secrets font awesome not found. Oh yeah, so I forgot. Okay, so in our demo cluster, what I think we need to do is submit. Here's what we got to do. Let's see, we gotta run some Ansible. Actually, I'm gonna OC log out and generate a new token. One sec. Oops. So okay. I'm gonna share my screen again. All right, here we go. So instead of running the deploy all that we ran in my previous video, we're gonna deploy font awesome.yaml. Oh, let's see. Okay, hang on. I gotta deploy that secret. So then I'm gonna deploy that font awesome secret in the Smart Aquaculture namespace. Okay, now I'm gonna share my screen again. Share. Okay, so this is the secret, font awesome. It's in the Smart Aquaculture namespace, and then I run this Ansible playbook, and it should add that secret to each workbench namespace. So it added it to workbench user 01, and it added it to workbench computate. Good. So then we come back here and try this again, see if this works. Okay, now it is indexing all the source code. So what's happening here is if we go to networking routes, solar and access our solar admin. Let's see. So I got to type in admin here and then grab a secret solar, copy the password and then put it in there and log in and save that. All right, so collection, I go to computate user one and query, execute query. So what it's doing is it's indexing source code for Smart Aquaculture. So let's see how it did. It says it indexed information. So I should be able to check if I set rows to 0, then execute query, and then I set facet field to this. It's in French, signal storage string, and then query this. Let's see here. See, no, what I actually need to do is change this to indexed, and execute this query. So it shows that there are 231 Java-related classes, fields, methods, constructors related to Smart Aquaculture now in this search engine. And if we do this, Smart Aquaculture, we add that field and then a colon, smart-aquaculture, and we change this to 10. Then we query this. So this is information about little chunks of code, like the base results that's stored in the search engine. And next, it tells us to run this in a terminal. So I open up a terminal and I paste this in. And then it's going to watch our code for changes from now on. So it's watching. And then we do the next step, which is create this site user.java file. So I run this. It's going to create a site user.java file up here. Okay. So model user. Refresh. The site user.java. Okay, here it is. And then we create this site routes. .java site routes.java. So created this file where we can add additional routes if we want to. And then the Now here's where maybe I need to fix something in my automation because it should have automatically recognized that this site user.java file was added. But for some reason, I think I need to touch it manually here. Let me just see, go to definition. Okay, so yeah, so now it's recognizing that site user was created and it's generating code for it. But I think we need to save this one more time before it'll be happy. Okay, so now it says it's touched. So site user gen page.java. See if this looks better. Okay, I think it fixed itself. So it was busy generating code. Now let's continue and generate the worker vertical.java. So it recognized that this file was created and it generated a class behind it called worker vertical gen. Worker vertical gen.java. This is the generated code. And then we're going to generate the main vertical, which will actually run the application. Over here, main vertical.java. It created this, plus it created this generated file, main vertical gen.java. And then we need to generate the page layout. We generate the page layout last because it depends on what models have been deployed. It'll regenerate the page layout with a nice menu of what all the models in your site are. Currently, we have no models, so it's going to be a little bit empty. But that's all the code that we needed. So the next step is to run Maven clean install and see if this actually works. So we're going to run Maven clean install. Run this code in a new terminal. We do that because it generates a lot of logs and can make the workbench slow down when it's run within the Jupyter Notebook. So we do it outside of the Jupyter Notebook because it's got to download all these dependencies. I'm going to actually try to simplify these dependencies because a lot of them are unnecessary. But I haven't quite finished optimizing the dependencies in the project. So this will take a little bit, but hopefully it'll work. I'll show you around the code. So we have, let's see, we have Smart Aquaculture here. We have the container file, which is how it would be installed as a container and run. So you you grab this image built by Red Hat called registry.access.redhat.com/UBI9, which stands for Universal Base Image that Red Hat provides for free. And then the OpenJDK 17 version of it, the latest. And then we run as user root. We install the Git package, and then we create a directory. This is the container's home directory /home/default. And then we create a subdirectory called Smart Aquaculture. And we copy the source code into that new directory. And we clone the dependencies of Smart Aquaculture. These are always being developed, so I always get the latest. Oh, we did not. Okay, for this, to resolve these, we need to regenerate the worker vertical and main vertical. Let's just look at that source code real quick. Main vertical.java. And let's see where there's an error in the code. It says main vertical bad source file. Let me check this source file. B, P, paste. Oh yeah, okay, so this was not successfully created. So let me go to site page.java and resave this. Okay, now that generated the code that we need. Oh, wait. See if this works now. CD Smart Aquaculture Maven clean install. So where did we go wrong? In site page. So this depends on code generation. So we should move it down to here after we start watching the code for changes. And then hopefully that'll fix that problem. Okay. Oh, this was a recent change that I made. So main vertical, whoops, MQTT host. It's in main vertical, MQTT host. This should be host underscore name, MQP host. Okay, so then worker vertical MQTT host name. Okay, that looks good. Let's try this one more time. I'm gonna make a note to fix that. Okay, build success compiled. That's exciting. So the next step, let's see what it says here. We compiled this. And now we refresh the Maven projects in VS Code, regenerate the API. It's going to it's going to generate an open API spec, a PostgreSQL database schema, set up the PostgreSQL schema in the database, and create the FIWARE context. Oh yeah, so let's see. Rebuild API text. And it says select rebuild API. So I come to run and debug, and it actually says rebuild Smart Aquaculture API. So we run this, and hopefully it's gonna, then it always says, then fix. And I explain, click the fix button, and then we choose main vertical, and then fix again, update project configuration. And then for the last time, we try to run this, and oh, let's see. Come on, you can do it. Takes some time to fix. I think I'm being impatient. So then let's try this one more time. When it's ready. Come on. Continue. Oh, I gotta hit continue. No. Let's no class defined error. Come on. I know this works. Fix. Smart Aquaculture main. I think I need to refresh the page. Let's try that. All right. Cancel. I need to switch to rebuild Smart Aquaculture API. Now it's acting like it's working. Compiling, launch configuration. Now it's running. Good. Connected to Zookeeper. Oh, we got another failure. Source main resources. Oh, I need to make it create this directory automatically, I guess. So copy terminal. I'm going to use this terminal. So I got to fix this in my course, but install -d, create that directory, and then let's run it again. Okay, so what it generated was, close all, db-create.sql, create.sql. So it created a database table for site user, and it also generated the Open API 3 in US spec. And now we can run our site that's based on this Open API spec. We can run this, and it says it's running. So let's check. I gotta go up here. Let's see where's it? No, clear. I'm gonna run this again. Let's see, I got a little lost. So it says it's serving the application here. So we control click, we click configure trusted domains, trust. And now we have an actual running site. And if we log in, then we can log in with our user one credentials. See, I copied the password here. Log in, allow. And then it has me fill in some details. So I'll say user1@mailanimator.com, user1 submit. And I'm in my site. The Font Awesome icons are not working, but I'm going to have to fix that too. But we have a running site and we did it all from VS Code in a browser from scratch. So pretty cool. Anyway, for more details, if you want to learn more, go to my website, computate.org, and you can learn more about the Smart Aquaculture. This is the webinar, and you can join again tomorrow. And there's the link to the webinar and the dates, and you can read the use case for Smart Aquaculture. And then, let's see, I'm going to put the latest events coming up on here as well. But we got the workshop in Pennsylvania next week and the workshop in Boston in May. So check that out. See, I got to figure out why the map's not working right now, but check it out. Thanks for watching.